All right, hello everyone. Welcome to another daily dose of LeetCode featuring new questions. So yep, let's get right into it. We left off yesterday on page 3. So doing some pretty good work here. One thing that I like is I like to see all the green marks starting from the top. It's nice to know that we're just going in order and everything's just coming out looking right. So let's just get into our first question here. So sign of the product of an array. There's a function signFunc that takes, or that rather that returns 1 if x is positive, -1 if x is negative, 0 if x is equal to 0. You're given an integer array nums. Let product be the product of all the values in the array nums. Sign function. The product of all values in the array is 144, and the sign function is 144. So let's see something. 0 if x is equal to 0, there's a function that returns, and they want us to get 0, 0. Okay, so I already know that one of our base cases here, at least one thing that we could stop on, is going to be if we ever get to a 0, right? So let's just say we want to get the product of all these different digits, right? Now, to be completely honest, I have done this question before. And let me talk about one thing that I tried. I remember the first thing I tried a little bit naively, the first time I ever tried this question. And what I did was that I just tried to multiply every single number together. But as you can probably imagine, some of these numbers can get pretty large in size. For example, like they can be less than or equal to 100. So that quickly went out of bounds. It quickly overflowed. Really, all they care about, they don't care about the number itself. They just care about the sign of everything multiplied together. So instead of having to necessarily worry about the value, if it's negative, we just make it negative. If it's positive, we make it positive. And if it's a 0, we can just return 0. That's like the main takeaway here. So that being said, we can do this. We can go through every single number. And actually, we can do for const n of nums, right? If n is equal to 0, we can just return 0 immediately, right? If now we say math.sign of n, if that's equal to 1, and actually we can even condense this. We can say if math.sign of n is equal to 1, then we could, let's see, math.sign of n equals 1. We can just say product equals, if this is equal to 1, we can say, or this one, right? Product times or equals 1. Or what's like, you know what? I think a ternary statement here is just making this unnecessarily complicated. We can say if math.sign of n is equal to 1, we'll say product times or equals 1. Else product times or equals -1. Here, let's see, 1, 1. If it's -1, we'll return -1. So let's just say return math.sign of product. One and one. So, well, we'll see what the different questions or the different answers are here. 1, 0, -1. All right. Cool. 75.03. So like I said, I've done this question before, but it was a little bit strange in the sense that like I tried to multiply every single digit together, but like I said, that quickly overflowed. So instead, like I said, we don't care about the value, we just care more about the sign of multiplying each individual one. If it's a -1, if it's a negative number, it'll just be a negative result, right? If it's a positive, then we'll just do the math whenever we get there. So hopefully that made some sense to everyone. Starting off with a decent question. I think it's a highly rated question because this right here, or rather because of the issue with the overflow, right? Sweet. Let me have to step out for like a minute, so I'll be right back. Let me sign into chat here. Let me see, stepping out for a minute. Be right back. So I'll see you all in a minute or so. All right, thank you all for waiting. Let's get right back into it. So am I live? I am live, right? Okay, cool. All right, let's get to the next one. Calculate digit sum of a string. Oh, nice. Another high quality question, perhaps? So you're given a string S consisting of digits and an integer K. A round can be completed if the length of S is greater than K. In one round, do the following. Divide S into consecutive groups of K, such that the first K characters are in the first group, the next K characters are in the second group, and so on. Note that the size of the last group can be smaller than K. Replace each group of S with a string representing the sum of all digits. For example, 346 is replaced with 13. Because 346, oh, okay, I see. Merge consecutive groups together to form a new string. If the length of the string is greater than K, repeat from step 1. Interesting. Okay, so I was almost thinking we have to divide this into similar numbers of size K. So it would be like we take 3 Ks here, but then we can only take 2 1s, or 3 1s and then only 2 1s, but it looks like we can do a 1 here. Then we calculate the digit sum of each group. So that's 3 and that's a 4, 6 and 3, 5. So S becomes 3, 4, 6 plus 5. After the first round, for the second round, we divide S into 3, 4, 6, and 5. Calculate the digit sum of each group, 3, 4, 6, 13, and 5. S becomes 1, 3, and 5. After the second round, now S dot length is less than or equal to K, so we return 1, 3, 5 as the answer. Okay. It seems manageable to me. One nice thing that we can use here is we're already getting a string, and string.slice in JavaScript. Let's say we start at this last index and we try to get 3 indices ahead, it'll still only give us the one thing. So I think because of that, what if we do something like, let's see, I want to make a copy of my input string. So let's make a copy of S. I want to do this. Slicing into modulus 3. I'm not sure what you mean. By the way, what's up, MMD? Good to see you again. Slicing into modulus 3. I'm not sure what you mean by that, but we can figure it out. Yeah, just drop it in the chat. So here we want while copy.length is greater than k, we're going to do some stuff. All right, and that stuff is first we're going to, I think what we can do, we can say for let I equals 0, I plus k, let's see, I is less than 0, but I don't want to go through, I think, yeah, it could just be I less than s dot length, I plus or equals k. I think we can do this, and we can have something like const slices. Here we can say slices dot push copy dot slice of I to I plus k. You can split a string into slices that divided by 3 is 0. You can split a string into slices that divided by 3 is, oh, well, yeah, I guess that will give me however many slices I can come up with. But what I'm thinking about doing here is like I need to get all these individual slices, right? So imagine I start here and I have my I variable, which is the one that I have in this loop. And then I'll create this empty array up here that represents my slices. So let's say I take, right, the first time, I'm going to go I equals 0, I less than s dot length, I plus or equals k. The first time I can go from I to I plus k, so from 0 to 3, which will take these first ones. It'll push this into slices, and then I'll increase by k, right? So I'll go 1, 2, 3. I'll do the same thing here. So 1, 1, 2. I'll take this, and then I'll go 1, 2, 3. I'll take this. I'll go 1, 2, 3, and then I'll just take this. Right? 2 and 3 is 5. So then I should end up with something like this. Like this is what slices should be after I do this. And now inside of here, I should be able to get the sum of each one of these individual ones, and I can create a new string based on that. But that's kind of what I want to set my copy to. But let me just remind myself real quick. If I go here to console, and I'm actually going to do the same thing they're doing here. Let copy equals s. Does that create a new? Okay, yeah, that's fine. 1, 1, 1. Okay. Slices dot push. So if I did copy dot slice from 0 to 3, that's going to give me 1, 1, 1. Okay, so that'll be a single array that I get in there. If I get the sum of these, it'd be nice if this was already, if these were all like digits. Now, can I just set this to be, I think actually I want copy to remain as a string. I don't want it to be an array. I think I can just do this maybe. I think I just want to do this. So here I have my slices, and now I have to add each one of them, which is kind of like the annoying part. But, or do we? Yeah, we do, right? Because that's just going to be string. Do I really have to do like parse int of each one? Calculate digit sum of each group. Yeah, I guess what we can do here, we have our slices. We're now pushing everything into slices. Now for each slice, right? For const slice of slices, const new copy, this can just be equal to a string. It's going to be a lot of weird stuff we're doing here, but we'll have to, yeah. I think what we can do here is I can actually just reduce this. Let's see, const sum is equal to what's the best way for me to do this? Can I do slices, copy dot slice? Can I do reduce on a string? I don't think I can do reduce on a string. I definitely can't. I can say let num equals 0, slice dot for const c of slice. Here we can do num plus or equals parse int of c. We'll do 10. So now this will give me 3, and to new copy, I can add 3. So new copy plus or equals num, or maybe we can just say string num like this. Once new copy is done, copy.length, that's going to be a string. I can set copy equals to new copy. Return 135 as the answer. So copy equals new copy, and then at the end, can I just return copy? Let me see. Kind of went through this really quickly, but I want to see what we get. New copy plus or equals string. Oh yeah. Let's make that a let. Let's run this again. Oh, copy.length is greater than k. Am I ever changing? Let copy equals s, copy equals new copy. Let's see. Oh, and we're not even going to be able to see. Well, let's think about this. We're going to go through this step by step. So we have this string right here. Copy is equal to s. Okay, cool. While copy.length is greater than k, it is. We're going to create our slices now. I is equal to 0. We're going to get these 3. We're going to push it in here. I plus or equals k. 1, 2, 3. We'll slice these. Push it in there. 1, 2, 3. We'll slice these. Push it in there. 1, 2, 3. We'll slice these. Push it in there. Okay. Okay, so at the end, right? 1, 2, 3. That's already going to be out of bounds. So now we say new copy is equal to an empty string. Right, now we say for const slice of slices. Now we're looking at each individual slice, which is just a string. We say for const c of slice, we do num plus or equals parse int of this, right, individual one. 1 plus 1 plus 1 is 3. And we say new copy plus or equals string of num. So new copy right here should equal 3. Similarly, we're going to go here. We'll do the same thing. That should be 3, 4, 6, and 5. So at the end, we should get that copy is now equal to, yeah, copy is equal to 3, 4, 6, 5, while copy.length is greater than k. So 4 is greater than k. We do the same thing again. So now slices becomes 3, 4, 6, and 5. Let new copy. All right, const slice of slices. I feel like that should work unless there's, right, because I'm always modifying copy unless, what if I just modify, can I just modify s? I mean, let me just try to do that actually. It's not normally, I think it actually might end up just being the same. S equals new copy, s dot length is greater than k, it's less than k. What happens here? Oh, it doesn't like these. I know we're like pretty close. I know we're close. Okay, nice. Cool. So why, there's some weird thing there happening with copy. Well, let's see if it makes, let me make sure it works with the rest. 0, 0, 0. Okay, let's run this. Hey, okay. Yeah, this one was interesting. This one was pretty cool. But like, I'm very interested, like I'm curious why copy. If I was setting, if I was modifying copy down here, and then it would read from copy again when it gets up here, why wouldn't that work? Copy equals s. I'm modifying copy. You know what we can try? Let me like revert some of this stuff here. Let copy equals S. So we have S here. We have copy pointing to S. We have new copy. Copy equals new copy. Interesting. Like copy equals to S in the beginning, but then I'm modifying it down here to equal new copy. So when I come up to copy.length here, S. That's so weird. I hate doing string manipulation problems like this in Java. Is Java, well, Java has like string builder, right? Which is something that I don't know, I guess JavaScript has something similar. But yeah, I don't know, is it like hard to do in Java? Yeah, this is so interesting. Why is this not, I have an idea. We're gonna do something a little bit different here. Let me not show this. This right here is actually the code for my website that, funny enough, I accidentally, check this out guys, I deployed a breaking change and I'm going to fix it as soon as I'm done here. If you try to visit Raphael's list right now, it's down. How unfortunate. I have to get to this immediately, but we'll do it after the stream. And maybe we can talk about why that is. Anyway, well, I'll tell you right now real quick. I was using the Firebase SDK to be able to get data from Firebase, and I recently switched to Prisma. Because Prisma, I just think the API is a lot easier. It's a very popular technology right now. It's fairly intuitive. It's an object relational mapper. It's very cool. So I just switched to using that, and it's made my life easier so far. So, and now I'm also using MongoDB. It's pretty neat, but we can get to that later. Okay, so let's run this guy right here inside of Visual Code. I mean, we're gonna do this live, and I'll just call this. I'll save it right in here. Raphael's list, sandbox.js. Okay, nice. So we're gonna pass in. Let's see, digit sum. Let me open this up here. Let's do digit sum of this with k equals 3. Let's go ahead and set a breakpoint over here. And let's run this guy. Run and debug with Node, right? Node.js. All right, so what is copy here? 1, 1, 1, 2, 3. Okay, cool. I got my slices. Like, we know all this is gonna work, right? Local digit sum s const slices block. Okay, we have our slices here. Let's see. New copy. Let new copy plus or equals string.num. Oh, okay, I see. Let's go down here. Go all the way down. New copy is 3465. Copy equals that. Okay, yeah, copy equals, okay. New copy is 13500. Am I not? No, yeah, I'm also doing copies again. Copy.length. I should have gone through, but there's some other weird thing happening in here. 13500, 9000. Yeah, why are we? Oh, wait a second. We should just be getting a 9000 and a 1. Why are we also getting these other slices.push, copy.slice of I plus k, copy.slice from 0 to 900, and we increase it I plus or equals k. Now we just get the last one, I plus or equals k. Oh, I see what the issue is here. It's right here. This should be copy.length. because copy is changing. I think that's the issue. Let's try something. And why am I making a big deal about this? I'm making a big deal about this because ideally we wouldn't be changed. So there's this notion of like pure and impure functions. So in this one, I don't want to have someone pass in some variables and have them be changed or affect other areas of the app. So by us making copies, right, we're making copies of the input variables and we're like returning a new copy of that, right, without affecting the original input. So it helps us get to something that's more pure. It's very similar to like doing things in React. If you've used something like Redux before, like you can't modify state directly. You're always creating a new state, creating a copy of it and returning a new state, not modifying an existing state. So kind of a similar notion here. So I'm happy with both of these. Let's see if we can think about the time complexity here. So while copy.length is greater than k, I mean, k can be 1. And so this will probably go through every single digit, right? So I think because of this, we can say this is O of n. Again, here, k can be 1. So this will be another O of n. Const slice of slices, I guess, similar thing. If it's n, we'll have n things inside of our slices. This can also be O of n. And const slice of slice. I mean, you could say that here, this is technically going to be like however many slices you have versus the, because the amount of slices you have is the same. If I have 4 slices, I guess this could be different. Maybe this should be O of n times m. Maybe this should be O of m, because you can have a different amount of slices versus the amount of characters in your slice. So because of all this, it looks like so far we have what, like O of n. Someone help me out with math here, because I'm not good with math. Like the inner one here, right? This will be n by m. This will be O of n plus O of n by m. But then that whole thing is going to be multiplied by O of n. O of n times O of n plus O of n by n. So if we just remove this, like if we just do n, let's see, we're getting places here. Is this just n squared times m? Or n squared times nm? Something like that? Man, did I just forget how to do like algebra? Something like this. Maybe there's like a better way to simplify this. This is a LeetCode stream, all right? It's not math, so forgive me. It's been a long time. Luckily, software engineers don't need to be incredible with math. But yeah, I need to remember some of my the cumulative and the FOIL method and associative properties and all these things. Maybe there's a... I wonder if I can stick this into like Wolfram Alpha. If I do n times n plus n times m. Okay, slight tangent, but we're gonna Wolfram Alpha, very slight tangent. We're gonna take a second here. Can't you just put it and it'll simplify it? Alternate form, n squared mx plus 1 expanded mn squared x plus n. Oh, that's not x. That's okay. M time. Oh, does it think that this is a alternate form? Mn squared plus n squared, n plus 1 times n squared. Did I get that? N plus 1 times n squared. Ah, it's all right. I think you guys get the gist of it. Space complexity here. Let's see. We're going to be creating this slices array here. So I think that will necessarily make the space complexity linear. Let's see what the solutions have to say, or at least discussions. Probably going to be something, let's see, accumulate. That's awesome. Like, accumulate and just throws all this code at you. I have no idea what it means. Okay, replace the old string with the updated one, and then we have a for loop and another for loop in here. Upvote if it's helpful. This seems very similar to what we did. So I'm happy. Let's go back. Let's undo all our analysis comments here. Let's run this one more time. Let's see what we get. 26.09, but I'm good with that. All right, I think we're off to a pretty good start. I'm happy with what we've done so far. So let's do this next one. Wow, three pretty good quality questions in a row. That's almost like unheard of. Haven't really done that in a while. Okay, sweet, let's do it. A sentence is a list of tokens separated by a single space with no leading or trailing spaces. Every token is either a positive number consisting of digits of 0 through 9 with no leading zeros, or a word consisting of lowercase English letters. For example, a puppy has 2 eyes, 4 legs. Is a sentence when 7 tokens, 2 and 4 are numbers, and the other tokens such as puppy are words. So it's either a positive number or word, okay? Given a string S representing a sentence, you need to check if all the numbers in S are strictly increasing. Really? That one seems pretty easy. I mean, okay, we can do this just like going off the cuff right here. I'm going to say previous is equal to negative infinity. That's the one thing I'm going to do. I'm also going to get, actually, I'm just going to do it in line. We're going to do for const C. For const C of S, first I want to check to see if the thing I'm currently on is a digit. So how do we do that? Very simple. We're going to use a regex. If some of you watched yesterday, we were doing some regex stuff. Was it yesterday or 2 days ago? Well, either way, we're going to do an inline regex expression here. So if, I think I can just do 0 through 9 ig.test. Will this work? It's going to be cool. So this is a regular expression, right? With case, I guess we don't need case insensitivity or global. Regular expression, we're using the test method. This will return true if this value, if this argument passes the test. So that means that if this thing returns true, we're looking at a number. Here I can just say, let's see, const number is parse int of C10. We can say if number is less than previous, return false, else we can set previous equal to number and then return true at the end. I think this is something we can do. This seems okay to me. Let's run it and figure it out. Of course. Oh, haha. That's the catch. We did not think about that. We did not think about that. I mean, we could remedy that. We could make it easier. It'll take slightly more time, but yeah, what we could do, and this is any number, yeah, 0 through, I guess, what's the highest it can go through? Oh, this is interesting. Now, is it 0 through, every token is either a positive number consisting of digits 0 through 9 with no leading zeros, or a word. So if it's a 12, I have to consider both of those. So it's not that I just can consider one. Does it give me 3 consists 0 through 9 inclusive? Tokens, there are at least 2 numbers in S. Each number S is a positive number less than 100. Can I do regex number range? What if I don't want to do 0 through 9? Oh, to match any number from 0 through 9, we use D in regex. It will match any single digit from 0 to 9. To match a 2-digit number, to match a numeric range, to match any number from 1 through 9, to match numbers from 0 to 10. How about regex for number range 1 through 31, 0 through 99, 0 through 100. Interesting. So I really have to do that. Like 0 through 100 is what we want, right? Positive number less than 0 with no leading zeros. Is this the whole thing we have to use? I mean, is it cheating if I get this? Is 0 considered a positive number? Oh, 0 through 9 inclusive. What if we do, okay, let's try this. for const token of s.split at a space, we can test the token, but we're going to pass in this bad boy. Now, can I do this? This is wild. Const number, we're going to parse int of the token, previous number. Will that work? Hey, but wait. There's more. Let's see. I mean, for the sake of regex, true, false, true, false, false. Let me see. Is there something in here? 50s and 60s. True, false, false. Hello world. 5 by 5. And this token. Regex number 0, 1 through 12 range work as expected. You seem to have misunderstood how character class definition works in regex. To match any of the strings, 0 and then 1 can be 0 to 2. Or, oh, so does that? We're gonna learn something new today. We're gonna learn more about regex. We've been doing a lot more regex stuff recently. Let's see, if I input this. So wait, that does not work? 0, 1 through 9, or 1 matches a 1 character? Explanation. A character class by itself attempts to match 1 character from the input string. Okay, against any of the 3 characters. Beginners often make the mistakes of defining things like this or that. This doesn't work. How ranges are defined. Character class definition. A to Z. This means that A through Z and A through Z are equivalent in most flavors. Yeah, I would just want to see, 0 through 1 matches double digits between 1 and 0. Oh, so do we just want 0, 0, 0, 1? Okay, so if our max number is 100, I mean, we can have anything in between. So is that going to match? We can't do like 0 through 9, 0 through 9, 0 through 9. That only matches those two. So it doesn't also get 98 or anything like this. So now how do we make it get any of those? Like optional, I guess. Optional character class. Is that what the B is for? My patterns, cheat sheet. Word, not a boundary. Capture group. 0 or more, 1 or more, 0 or 1. I mean, could we do that? Oh. Man. Oh, wait, warning. Can return empty matches. Okay, it does 100, it does 1, it does 0, 56, 87. Ah, that's not good. Because this should just be 0. Oh, wait, 0 or more. If I just want 0 or 1, it should just be the exclamation. Shouldn't it be just that? If I do 0, 1, and then, oh wait, maybe this last one too? That also does 0 or 1. I'm just trying to make it positional though. 0 or 1, 1 or more. Match any characters that match between 0 and 1 of the preceding token. Let's think about this. How can I just check to see what happens if I try and do a parse int on a non-digit? Like if I do parse int on hello, not a number. Okay, so could we also do that instead of using regex? for const token of split, if, oh, but then I'm gonna have to do it, or I can just say const parsed equals parse int of token 10. So if it's not a number, I think there's a check against nan JavaScript, check if nan. I think there's like is nan determines whether a value is, okay, number is nan. Because coercion inside the is nan function can be surprising, you may alternately want to use number is nan. So if not is nan, first time ever using this method here, is, let me just make sure I have that spelled correctly. Okay, if not is nan parsed, then we can say number is parsed. Or we can just actually just do it again, right? We don't even need number here. If parsed is less than previous, return false. No, okay, we do need that number. If number as previous, return false, previous equals number, previous equals parsed. Do we? No, we don't need that. If parsed is less than number, return false, else previous equals parsed. Yeah, there you go. Let's try this out. True, true, false. So why are we getting if parse is less than previous, return false? Oh, it needs to be if it's less than or equal to, right? That took me a lot longer than I would have liked. Let's run it. 82.99. Let's keep going here. I'm just gonna run it one more time to see. So the split is gonna take, that's gonna take linear time, right? But is there a faster way that we can do this? Can't we just get everything in here that matches a number? Oh, but it's not really just also checking to see. It's making sure that they're strictly increasing. I can get a regex to get all the numbers and then maybe put that inside of an array, but I'll still have to loop through that anyway. Let's check discussions out. Track previous and current, okay. Previous, if is digit current, current equals current times 10 plus current minus 0. If previous is greater, yeah, that's cool. Pretty much the same thing we did, a little bit different, but is digit, we don't have an is digit function, so we try to parse it. At least I don't think there's a mdn is number. What happens if I try to use the constructor with a value that's not a number? It's rarely number, nan, prototype, static methods. Ooh, determine whether the past value is an integer. Now, does that only mean, like, is that faster is integer hello? False? Wait, can we use that instead? Parse int token. Maybe I can do something a little bit cleaner here. Let me cut this out. Here I can say if number is integer token. Okay. If parsed is less than or equal to previous, so now I want to parse it, right? Let's say if it's an integer, we parse token. And I guess here is where we will actually do the parsing. So I guess it's just a matter of, like, we'll still end up moving this guy inside of here, parse int token, and then parse less than or equal to previous equals parsed. But maybe that can just be like a nicer way of looking at it. Const parsed equals parse int token. What happened here? Oh. Let's see, true, true, true. Turn false. If number is an integer, token. So is it taking other things that will not be like world? True, it's an integer. Parse int token 10. If parse is less than or equal to previous, return false. Else previous equals parsed. That's strange. I'm not sure why we'd be getting that. But you know what? We already solved it, and it seems like it was at least with the discussions we're saying, so I'm good with moving to the next one. We've done 3 so far, so pretty amazing. Feeling really good about that. A substring is a contiguous, non-empty substring of characters within a string. A vowel substring is a substring that only consists of vowels and has all 5 vowels present in it. Given a string word, return the number of vowel substrings in word. Let me see, not all 5 vowels are present. Oh, the vowel substrings of a word are U, A, E, I, O, U. Oh, this is going to be fun. Count vowel substrings. And these are contiguous. So how are they doing this one? We have A, E, I, O, U. Okay, so we have, I think here, let's see, like this one, this is not inside of A, E, I, O, U, so we start here. So let's say we have our start here and we have our end. U is in there, A is in there, I is in there, E's in there, U's in there, O's in there, U's in there, and A's in there. So that's 1. And then what? Oh, and it also has to be, oh, this one. This one is good. This is a top quality question. I'm surprised this is not, or am I not thinking about this? Is there an easier way to do this? A, E, I, we have to go to the O to make all these. Okay. What can we do after this? I can also increase it and I'll have another one. I can also increase that and I'll have another one. Is there a better way of doing this? What if I don't even consider, what if I only consider consonants? Or let me see, this is lowercase English letters and we only have length of 100. If I took the frequency of each one of these. Wait a second, I think I have a better idea. A, E, I, O, U. Let's get our frequency going here, right? So we have a U. It's going to equal to 1. Then we have an A. We have an I. We have an E. We have a U. That's 2. We have an O. That's 1. We have a U. That's 3. We have an A. That's 2. We have a C. So how many 5s can I make out of this now? Vowel substrings of a word. Because I guess we're not counting them multiple times. Come up here, they figure this one out. Come up here, they figure this one out. This is not 1, so then we start backtracking until we no longer get to it. I think this is a sliding window problem. I'm not so great at these most of the time, but let's see if we can figure it out, because what we can do is sort of create a set here where I can say, let's say like the one I'm currently on is not a vowel, so we just go to the next one. This is a vowel, so we add it to our set U, right? Let me just like give myself some room here. I have to really, you know, I like doing this thing. So then we get to E, that's A. We can add that to our set A, I, E. Okay, now we get to U. It's still 4. We get to O, and now that's 5. Okay. So we got to an O. That's cool. Now, can we keep going though? Like, okay, U is another one. We're still at 5. A is another one. So we're still at 5. Now we get to C. Do I ever include? So we never include the C. But let me see. C is still... Like if I'm at the C and I realize that's not a vowel, do I need to somehow like backtrack to the previous spot? UOU, the vowel substrings of word are as follows, underlined. Vowel substring is a substring that only consists of vowels and has all 5 vowels present in it. How would we solve this, like if it wasn't... I can keep going because the next one, so I'll just keep adding that one. This one also has all 5, so okay, that's good. Start here, keep going, keep going, keep going. As soon as I get to the next point where I can't anymore, I start maybe backtracking from start to where I couldn't anymore. I guess maybe we could do that. Like, okay, so when n gets, I guess when n needs to, or how about when end is not a vowel, we increase s. And every time our set equals 5, we add. However, I also just realized though that like if we stop here, now we like, let's say we remove U. I can't remove U from this set because U is still represented here. So I think I might actually need to keep a count. I think I could keep a count of the different consonants as I go along. What if would it be beneficial for me to have a count? I think I know what I can do. I think I have an idea. I think I have another idea. And I think what we're going to do is actually going to get us like more leverage in the future. So imagine we have a pointer. Imagine we have a pointer that starts at C, right? And I start counting, I create like a frequency map to start counting vowels as I see them. So this could be my start still, and then I'll have J, which is now my end. I say, okay, I have 1 U at this moment. And my overall count equals 1. So the overall count happens, so overall count increases when it's a new vowel, decreases when it's 0. And I'll hopefully have a chance to explain myself more as we go along this. Decreases when it's 0. So U is 1. Then we get to J. We get to J, A is 1, overall count is 2. We get to I, that's a new one. I is 1, overall count is 3. We get to E, E is a new one. Overall count is 4. We get to U, U is not a new one, but we still add it. We get to O, O is a new one. Overall count is 5. So now, what can we do? Can we go from, let's see, is the start always going to be, maybe the start, to make it easier, should only ever be a valid one, right? So let's say now we can create a new string, which is this. Okay, cool. That's like our first string. Okay, now we can keep going. So I go to U. That's going to give me a 3. And my overall count is still 5. Right? So I can add this one too. I can get to A. I add 1 to A. Overall count is still 5. Let me also add this in here. Okay. Now I get to C, which is not a vowel. So now we can start increasing start. right? So anytime now that we increase start, we decrease u. So we're increasing start. Now we only have 2 u's. We increase a. That's going to give us 1a. Oh, but now I'm missing out on... Oh, no, wait. That's fine. That's fine, right? Because we're still at the u. Let's see. We already considered u to a. Now we increase I, right? We decrease u, but we still have 5. So we can add a through this one right here. Now we decrease a, so this is 1, and we increase I. Overall count is still 5. Now we decrease I. So now we decrease I, which is 0. So when we do that, we now have an overall count of 4, because not everything is included anymore. 1, 2, 3, 4, 5, but we have 7 here. So why am I missing? I did AE, AIE, UO, A, IE. Why did I miss the other ones in between? Did we not count them? Did we not count those? Still another one. We start increasing. Oh, but we're only increasing. Oh, this is so weird. Oh, I really thought we were onto something here. Because, like, why, like, in this piece, why do we only consider A, E, I, O, U? Like, how would I get there if I'm already at U and I went all the way to the end? Like, would I ever just, like, go in the middle here? What if I, like, sorted this just for fun? And I'm not even sure what that would look like. But we can try, like, A. I'll remove an A. Let's put all our A's in there. Okay, I think we have, what, 2 C's? AACC. We have 1 E. We have an I, O, and UUU. Like, how many? I can do like a E, I, O, UUU. Well, I can do an A, an E, I, O, and a U. I can do an A, an E, an I, O, UU. But then there also has to be in the right. Oh no, it just needs to be the count, right? Yeah, maybe the frequency thing is one thing that we can do. So I have 2 A's, 1 E. So each one of these can go with, I can do A, E, I, O, U, A, E, I, O, U, U, A, E, I, O, U, U, U. I can also do A, E, I, O, U, the same thing over there again. But then I guess we can just do like A, E. Yeah, they're coming up with like a lot of different ones here. Or is that all of them? A, E, I, O, U. That's 1, 2, 3, 4, 5, 6. So where's the 7th one? A, E, A, E, A, E, I, O. Oh, the 7th one is both of the A's together. I wonder if can you guys see what we're doing here? Let me draw this out in Excalidraw. Let's delete this. Let's come up with our text here. So like, I want to make this really large so you guys can see. So kind of what we're doing, or at least what I'm thinking, is like we can do, there's going to be a lot of lines here, so get ready for this. We're doing like A, E, I, O, U. That's 1. And then we have A, E, I, O, U, U. That's 2. A, E, I, O, U, U, U. That's 3. And then we also have this one down here, right? It was A, E, I, O, U. We have A, E, I, O, U, U. A, E, I, O, U, U, U. And then finally we have A, E, I, O, U, U, U. But like, why can't we just do A, E, I, O, U? Maybe that's Because now there is 7 here. A, E, I, O, U, A, E, I, O, U. Yeah, they're also considering those too. Yeah, I really thought that would be a way for us to do it, but A, E, I, O, U, A, E, I, O, U, U, U. Count vowel substrings. Contiguous non-empty substrings of characters within a string. I mean, we just want to find all the words inside of here that are only made up of vowels and have at least all 5 represented. The confusing part for me is like this right here, like the mid piece. Why would I only consider, unless, I mean, can we start from, wait, can we start from the outside? What if we did 2 pointers from either side? Because if we did that, could that work? No, but then how do we know to go left or right? How do we know to go inwards? We're reaching the hour here, so this one might have to take a pause into a weekly roundup. But let's see, you know what, to make it up, let's see if we can find, let's see what this design hash set is all about. Design a hash set without using any built-in hash table libraries. Add key, contains, and remove. Now, when they say, okay, built-in, can I just create like could we do something like this hash equals this? Add. 1, 2, 1, 2, 1, remove 1. Prototype.add, let's see. So we can just say this.hash key. Wait, but add is what? Oh, it just wants me to add. Okay, well, can we just set this equal to true? Key equals true. This prototype remove, return true. So if this dot hash of key equals undefined, will remove always be called on a valid? If key does not exist, do nothing. Okay, so only if this dot hash key is not equal to undefined, removes the value key, can we just do delete this dot hash key? Prototype contains, can we do return this dot hash dot key not equal to undefined? Because contains will be, so we say add 1, okay, add 2, contains 1, hash dot key is 1 is not equal to undefined, true, not found. Add 2, okay, contains 2, yep, contains, remove 2, we deleted it, so let's run this. No, true, false, no, true, no, false, okay. I mean, am I using any, I'm not using a library, right? I'm just creating my own. I mean, I think that's what they want, hopefully. Submit it. 87.31. I mean, I hope this is what they want me to do. I think it's right. I don't feel like I'm using any built-in libraries or functionality here, right? I think I'm well within my bounds here. So I'm happy about this. I just wanted to do maybe one more, that way we can make sure we end up on a good foot. So what I'm going to do right now is I'm going to update my website to make sure that's not failing anymore. Because right now it's completely down, and that's a big no-no. And I'll make sure to update some of the questions that we did today, because the ones I did, like, let's go over all of them today. So we did this one, this one, this one, and this one. So we only did 4? Yeah, we only did 4. I like this one because this sign of the product of an array can be tricky. You can get into some overflow issues, which I think that's a worthwhile thing. I think this question's pretty good. I think I like this question. So I'm going to add this to my list. This one's like failing to load. This one, I think this one's good. I'm going to add this to my list. Design a hash set. I think this one's good because you'll definitely get practice with the data structure. So yeah, we'll at least get 3 new ones. I suspect that like the count vowel substrings of a strings will probably be added once we solve it. I don't want to add something I haven't solved yet because then I can't link to the stream. So with that being said, thank you all so much for checking in on today's stream. I will be doing another one tomorrow. Apologies for being a little bit late today. I had to handle some stuff, but tomorrow let's hope that we can make it on time, 5 p.m. Eastern for everyone. I'll make sure to update everything. Thank you all so much again for joining. Thank you all so much for the support. Looking forward to just communicating more with you all. Leave comments, talk to me. Let's make things happen. Have a great rest of your Wednesday, I believe it is. Already Wednesday? Yep. Good luck and happy coding. Later, guys.